Hello there. Hey, ready? Super psyched to be. Thanks so much for putting it all together. I'll have slides which I'll show later, but I'll share them later. But they're not too much interesting visuals, so I'll skip them for now. A thing where everybody's reading the slides like 3 words ahead of me, and so cool. So my name's Ben. Been at Datadog for a couple of years now. It's been a pretty exciting time for dev efficiency here because the company's been growing so quickly, and so we keep seeing things break that used to work, and sort of a rundown of some of the tooling we use, which has been a huge help in the growth of the team here. So a brief history of the team. Datadog's been around for a few years. Dev efficiency only started in 2016, in the team at the beginning of for 2017. For the last year, it was we were 4 people for a lot of the year. Now we're sort of 5 and an intern. We have a pretty large surface area, so we work on the development environment. Some of the other dev tools that folks use, locally. We work on the build infrastructure. Some of our key repos, kind of like mono-ish repos. We work on the deploy tooling. We work on some incidence response tooling, and other odds and ends. So it's sort of a big surface area for relatively few people, and so we've had to be very careful in how we approached it. And as we grow, though, we're splitting off responsibilities so that we can specialize and focus a little bit more on particular areas of this. So within the dev environment, in the very bad old days, in the before times, people would have to manually set up everything on their laptop. Stopped working well, like quite some time ago, well before I joined the team. And so then for a while, the second iteration of this chef set up to provision a laptop or a VM and get all the dependencies and everything needed, have the stack running. So Datadog has a web app, and then there's like a whole slew of microservices that sit behind it. And so getting that stack set up, there's a lot of moving pieces. So the second iteration was this chef thing. It was kind of brittle. It was very slow. When people had to rebuild their VMs or whatever, it would take quite a long time and a lot of fiddling. So the third iteration of this was to build a VM and use Vagrant and VirtualBox. And so and they more or less run Vagrant init, Vagrant up, small Datadog stack running in a VM on their laptop. And so it's been super huge for people to be able to just hit the ground running as they onboard. And not waste any time, jumping through a million hoops to get all these fiddly pieces connected to each other. The way we build the VM is there's a lot of pieces that go into it, but at a very high level, when folks deploy the sort of production build deploy process also creates a set of debs for each of those services that are the dev build of them, not the prod build. And we also there's a bunch of dev config in debs. We have several data stores that need a bunch of state to run the dev stack out of the box. So we ask that state, and then we dump those data stores also into debs. And so we wind up with this big collection of packages that represent a lot of the dev state, and we store those in S3. And, when we do the VM build, we install a lot of dependencies, and then we install these debs and wind up with all the services that we need and all the data store state that we need and all the config we need dropped onto the box. It's kind of a janky build, but we're always a work in progress. And back in the day, we had this weird snowflake box doing this build because doing VirtualBox builds. And the cloud is like steering it, but that became a pretty difficult pain point eventually, and nobody really liked having all of this stuff running on this like weird box that worked differently from everything else. So we moved the build into the cloud. We had to jump through a bunch of interesting hoops to do that. Like, there's conversions of different kinds of image formats. We're downloading an Ubuntu image to be the base, and then we're like converting the image of that and loop back mounting it with an offset to skip the MBR. And it's like all this like horrible stuff. And we wind up with this VirtualBox image that we can distribute. And so that's pretty swell. We have a bunch of smoke tests, like smoke integration tests in there. We use bats. So after we've installed all these packages, just like make sure that, flow through the whole pipeline in dev and all that sort of stuff. Make sure all the services start up properly that we need. I mentioned S3. We distribute via S3. We have a big engineering office in New York. We have a big engineering office in Paris also. But so we wanted to, so we replicate the VM is kind of big. We replicate that to S3 in Europe also. And then we have proxy service that sits in front of it that does auth and then gives out pre-signed URLs to the file in S3 so that folks can download it as quickly as possible from their nearest S3 location. And also, this is just a tangent, but we build the same VM that we're building for folks to do dev in. We also build a container version of it, which we use as the image that we run CI in. Some of our core repos an environment identical to the dev VM, and the idea there was to make it very easy for people to debug their problems, make it easy for them to understand how to set things up in CI because it worked the same way as their. I would say practice that's had some upsides and some downsides, but the upsides are awfully nice. What else? So we've got all these different services running in this VM, and a lot of people, are only working on one or some subset of these services. And so we have a construct we call package mode versus dev mode for each of these services. So basically in the VM comes with all the services, and you run vagrant up and one or two other commands, and you've got the whole stack running. That were built as part of the production build deploy for our services. For folks that then want to like hack on one of the services, they can run a command and put that service into dev mode. And what happens is the VM, we have some scripts in the VM which will swap out some symlinks. So instead of the service running out of the version that the symlinks will then point to a working tree that's NFS mounted from the host. And so it's like work in their normal editors on their host, do their normal workflow, and the rest of the VM integrates neatly with the service that they're coding on. To sort of first approximation that can be toggled by service, so folks don't have to build, don't have to deal with the services they're not working on. That stuff comes out of the box, and the stuff that they are working on, they have a sort of like very simple or sort of like low friction workflow to type some code, like restart the service and have it running with everything else. It's been a huge success. It's not perfect, but it's just the folks on day one getting their machine set up and getting off to the races works really great. Like their dev state got into a weird state and they just want to like have a clean slate. They can just like vagrant destroy and bring the machine back up, and that's like it used to be very time consuming, and now 5 minutes, 10 minutes later, like you've got a brand new clean slate dev environment. We also we do dev surveys them this year, so we've had a couple of them so far, and the dev VM has been the most like one of the questions we ask is what's the tool that you like best here, the thing that works best, and both times like number one response to that question was the dev VM. So that's been that's been like super handy. It doesn't work well for every single team. Some of our teams is for folks that don't know, I should have said this earlier on Datadog, we do infrastructure and application monitoring. And so we have these huge fire hoses of data, time series data and events data and all this stuff flooding in. And so for some of the folks, of course, that are doing, working on these high throughput systems where, they want to be testing, the efficiency of the throughput of these systems, like the VM is probably not a perfect fit, or folks that are working on very complicated, we have a custom time series database. And, for some of that kind of stuff, it's not a huge fit, but for a lot of the teams, for a lot of the services, it's been really, really great. And the future of this is with this, I guess, two big pain points right now. But the sort of fundamental one is that as the company keeps on growing, as the stack keeps on growing, we have more and more services, we have more and more stuff running in them. We're just beginning to reach the limits of what can fit on a laptop. Available to a local dev is starting to become insufficient to run. So people run subsets of the stack. People run metrics pipeline, and so I'm just running those services, or I'm working on the alerting system, so I'm just running those services. But for folks that want to run a bunch of the stuff, and even sometimes within just a particular feature, a particular slice of the app, we're running up against laptop. So we're actively investigating sort of what the next generation of this will look like. There's a good chance that, basically some of it's going to have to run remotely, and maybe some of it still runs locally, figuring out what the right patterns for our teams and our devs are. We may wind up doing some Kubernetes stuff, which we're looking into for everything. We have a staging environment right now. We have some of the problems that some folks have, with staging environments, trying to do the mirror of prod type thing, and we may wind up with some convergence with staging where we're running more of the stack and able to scale it a little bit bigger because it's out in the cloud. And yeah, that's something that we're looking into right now a lot to figure out what the right answer is there for the sort of the future of this development environment and the future of our staging environment, and plays together. So that's the sort of high level, relatively quick walkthrough. I'm more than happy to talk more about any of the details anywhere there, or that anybody has about any of this.
Thanks, Dan. Does anyone have any comments or questions?
I was intrigued by what you were saying about package mode versus dev mode, and wondering if you could elaborate on the difference between those and what advantage you gain from making that difference.
Sure, yeah. So most of the stack is a combination of Python and Go. So, let's say, you join a team that's working on the Python web app, and they show up on day one. They don't have to clone the repo that has all the Go code. They don't have to install Go, set that all up. They don't have to, do any of that build. They don't have to worry if or maybe they've got that all set up, but they don't have to worry about there being a version of the Go code that is compatible or something with the Python code. If maybe we had an incompatibility at some point there. The thinking was that if you're working on this service, you just shouldn't have to think about any other services at all. VM out of the box, means that, and it should be sort of a reversible decision, right? Maybe wants to play with the Go stuff a little bit. They've done some crazy building of the Go code, or whatever. It's not really language specific. There's some service that they've been tinkering with and built some crazy version of this code into the dev environment, and then they want to go off and work on some other service. So we wanted a way that was really easy for them to restore the first service back to a clean, known good state. And so being able to put that first service back into packaged mode, which just restores all of those symlinks, so they point to the version that was bundled with the VM originally, means that hop in, like tinker with something, and know that service is going to continue to work well when they're working on other things that may depend on it. Does that make sense?